Two groups, same continent of origin, 100 years of separation. Yet their DNA tells two completely different stories. What happened in those centuries that created such a dramatic genetic divide between Black Brazilians and Black Americans? The answer lies in decisions made in government offices, churches, and bedrooms across an entire hemisphere. For the longest time, we assumed that race was a simple biological fact. You were either black or you weren't. Your ancestry either came from Africa or it didn't. But when modern genetic science finally arrived with the power to read the complete human genome, it revealed something far more complicated. The DNA doesn't care about the categories we invented. It tells a story that's messier, more human, and far more revealing about how history actually shapes who we are at the molecular level. This revolution in genetic science didn't happen overnight, but in the last 20 years, the cost of genetic sequencing has plummeted dramatically. What once required millions of dollars now costs a few $100s. This democratization has opened new possibilities for understanding human ancestry and the complex relationship between genetics and race. Imagine two men, one from Salvador, Brazil, and one from Atlanta, Georgia. They both identify as black. They both have deep roots in their respective countries. They both grew up in communities shaped by African heritage, music, food, and culture. But if you took their DNA to a laboratory and broke it down into its component parts, you would discover something startling. These two men, despite sharing a common African heritage, carry entirely different genetic blueprints. That difference is not random. It's not coincidental. It's the direct result of centuries of specific historical choices made by European colonizers and governments in two different nations. When scientists began analyzing the genetic makeup of populations across the Americas using advanced DNA sequencing technology, they started to see patterns that were almost shocking in their clarity. The research teams found that African Americans in the United States typically carry DNA that reflects contributions from three major continental regions. On average, African Americans possess approximately 73 to 81% West African ancestry, 18 to 24% European ancestry, and less than 1% Native American ancestry. These numbers vary by region, but this is the general pattern that emerges when you look at millions of data points. Now compare that to the overall Brazilian population. Brazilians as a whole have approximately 59% European ancestry, 27% African ancestry, and 13% Indigenous American ancestry. When you focus specifically on Black Brazilians, the numbers shift, but not dramatically enough to match the pattern seen in the United States. The genetic signature of Brazil is fundamentally different. This is where the story becomes truly fascinating because these numbers are not natural variations. They are the direct consequence of policy. To understand how we got here, we need to travel back in time to when these two nations were being formed. When Portuguese colonizers first arrived in Brazil in the year 1500, they encountered a land already populated by millions of indigenous peoples. Over the next 350 years, they would transform Brazil through a process of colonization that was both similar to and strikingly different from what happened in North America. The Portuguese brought enslaved Africans to Brazil, not in small numbers, but in massive quantities. From 1500 to 1850, approximately 3.5 million African captives were forcibly shipped to Brazil. This makes Brazil the largest recipient of enslaved African people in the entire Americas. More than half of the Brazilian population today is estimated to be descended from these individuals. But here's what makes Brazil different from the United States, and this is crucial to understanding the genetic divide we see today. The Portuguese colonizers did not establish the same rigid racial segregation laws that would later define the United States. The mixture of peoples in Brazil happened on a massive scale. Intermarriage between European men and African women was common. Children from these unions were integrated into society in ways that had no parallel in North America. Over centuries, this created a population that was far more genetically mixed than what developed in the United States. The United States, by contrast, inherited a very different colonial legacy. The British colonizers who settled North America established what historians call a racial caste system. This system was based on the principle of racial purity and separation. Laws were created to prevent intermarriage between racial groups. Children born to mixed-race unions were classified as black, following what became known as the one-drop rule. The rules were brutally enforced. Slavery in the United States was not just an economic system, it was a racial system, designed to keep populations separate and distinct. When slavery ended in Brazil in 1888, the government made a conscious decision about the nation's future. They did not want Brazil to become a black majority nation. They actively recruited European immigrants, particularly from Italy, Spain, Germany, and Portugal, to come and settle the country. This immigration policy was explicitly designed with racial motivation in mind. The government wanted to, in their own words, whiten the country. This was not accidental. This was deliberate policy. Millions of Europeans arrived in Brazil following abolition. Italian immigrants alone numbered in the hundreds of thousands. The Brazilian government saw slavery ending as a crisis and chose to replace enslaved African labor with free European labor and alter the nation's racial composition. Scientists analyzing genetic data can see this moment in history reflected in the DNA. The genetic signatures of people from different European nations show up in the Brazilian population in proportion to how many immigrants came from those places and when. When they look at Italian genes, they show a sudden increase in the Brazilian gene pool starting in the 1870s. The same pattern appears for Spanish, German, and Portuguese genes. The DNA is a historical record written in genetic code. Meanwhile, in the United States, African Americans were experiencing the opposite trajectory. Segregation laws were being strengthened, not loosened. Immigration from Europe continued, but it was not directed to black communities. The Jim Crow laws that emerged after Reconstruction created an even more rigid separation between racial groups. The genetic consequences of these two different historical paths would be profound and measurable. When researchers from Penn State University conducted one of the largest genetic studies of African Americans, they analyzed DNA from over 5,000 self-identified African Americans across the United States. They compared this data to samples from West Africa and Europe. What they found was that the average African American individual carries approximately 17 to 18% European ancestry. This is significantly lower than what you find in Brazil. This finding surprised many people. Despite centuries of forced racial mixture, African Americans maintained a predominantly African genetic profile. The answer lies in social structure. Sexual mixture did occur, but the one-drop rule prevented genetic mixing from translating into social mixing. Each generation, the African American population remained separate, meaning the accumulation of European genes did not continue at the same rate it did in Brazil. The geographic variation within the United States is also revealing. In some cities like New Orleans, which has a particular history of racial mixing, the European ancestry percentage climbs to 22.5%. In other places, it drops to around 10 or 15%. But nowhere in the United States does it approach the levels you see across Brazil. This is not because African Americans avoided mixing with Europeans. History tells us that was not the case. Rather, it's because the mixing that did occur happened in a context of forced racial separation and the cultural enforcement of black identity, regardless of ancestry. Brazil, on the other hand, tells a very different story when you look at the genetic data. The research coming out of the DNA do Brasil project, a massive multi-million-dollar initiative funded by the Brazilian government to sequence the genomes of 100,000 Brazilians before the year 2030, is providing unprecedented insight into Brazilian ancestry patterns. These studies show that even among Brazilians who identify as black, the ancestry composition varies widely. Some have predominantly African ancestry, while others have significant European and indigenous components. What's particularly striking is what happens when you look at the middle of the Brazilian genetic spectrum. There's a massive population of people who identify as mixed, what Brazilians call pardo, and these individuals show incredibly diverse ancestry patterns. They might be 40% European, 35% African, and 25% indigenous, or they might have entirely different combinations. The genetic data reveals that self-identified race and genetic ancestry are poorly correlated at the individual level in Brazil. Someone who looks phenotypically black might have less African ancestry than someone who looks phenotypically white. This happened because of a historical process that anthropologists call asymmetric sex-biased admixture. What this means in practical terms is that the mixing of populations was not equal between men and women. In Brazil, particularly during the colonial period and the centuries of slavery, European men commonly had sexual relations with African and indigenous women. The children from these unions carried European ancestry from their fathers. But because these relationships were typically not socially formalized into marriages, and because the offspring were often categorized based on their mother's status, the population structure developed in a particular way. When scientists look at the maternally inherited DNA, which comes exclusively from mothers and is passed down through the female line, they find higher African and indigenous ancestry. When they examine the paternally inherited DNA from the Y chromosome, which comes exclusively from fathers, they find higher European ancestry. This genetic signature is like a written record of centuries of sexual conquest and mixing. The same pattern appears in other parts of Latin America and the Caribbean, but Brazil shows it in perhaps the most dramatic form because the scale of mixing was so enormous. The United States shows a different pattern. Here, too, sex-biased admixture occurred, particularly in the context of slavery where European men had forced sexual access to enslaved African women. But the social response to this mixing was radically different. Rather than integrating mixed-race people into the European community, American society classified them as black. The one-drop rule meant that any detectable African ancestry resulted in racial classification as black. This had a profound genetic consequence over time. The European genes that were introduced into African American communities through forced miscegenation never resulted in the kind of societal integration and intermarriage that happened in Brazil. The numbers make this clear when you look at the research. A massive study by 23andMe, published in the American Journal of Human Genetics in 2015, analyzed genetic data from 160,000 customers, including over 5,000 self-identified African Americans. They found that the majority of African Americans do indeed carry some European ancestry, but the amount is substantially less than what we see in Brazil. They also found that many African Americans carry a small amount of Native American ancestry, around 1% on average, but this is nowhere near the 13 to 15% of Native American ancestry you find in Brazil. The researchers from Penn State, who conducted the definitive study on American ancestry composition, explained their findings by looking at the historical patterns of migration and mixture. They found that regional differences in the United States reflected specific historical events. Areas that had experienced earlier Spanish colonization showed different ancestry patterns. Regions that received waves of European immigration at different times showed variations. Areas where African Americans had more freedom to move and intermix showed different patterns than areas with strict segregation. The genetic data was essentially capturing the history of American racism written in DNA, but perhaps the most revealing aspect of this research is what it tells us about how these populations think of themselves and how that relates to their ancestry. In a study conducted in São Paulo, Brazil, researchers examined the relationship between self-reported race and genetic ancestry. They found that individuals with higher African ancestry tended to identify as black, those with higher European ancestry tended to identify as white, and individuals with mixed ancestry were more likely to self-identify as mixed. This seems logical, but here's the crucial finding. At the individual level, this correlation was remarkably weak. Many people who identified as white actually carried substantial African ancestry. Many people who identified as black carried significant European ancestry. Compare this to what happens in the United States. Despite carrying substantial European ancestry, African Americans largely identify as black. Despite carrying some African ancestry, many European Americans identify as white. The genetic data suggests that racial identity in the United States is much more determined by social and historical factors than by actual ancestry composition. In Brazil, racial identity appears to have a somewhat stronger correlation with ancestry, but even there, the relationship is much weaker than you might expect. One of the most striking individual cases that emerged from genetic testing was the Brazilian singer Neguinho de Beija-Flor. His stage name literally means little black in Portuguese, and his identity was built on his blackness. He was a celebrated figure in Afro-Brazilian culture. When he took a 23andMe DNA test in 2007, the results showed that 67.1% of his genes were of European origin and only 31.5% were from Africa. The remaining percentage came from Asian ancestry. For someone who had built his entire identity and career on being black, this was shocking. Yet genetically, he was predominantly European. The story illustrates perfectly how contested the relationship between genes and identity actually is. The DNA do Brasil project is now generating vast amounts of new data that's allowing scientists to see patterns with unprecedented clarity. This project specifically focuses on historically underrepresented groups like Black and Indigenous Brazilians, which means it's capturing genetic diversity that previous studies might have missed. Preliminary findings from this massive sequencing effort are already revealing new insights. They're showing, for instance, that a genetic variant from African ancestry that actually protects against sleeping sickness caused by a parasite called Trypanosoma brucei is also related to an increased risk of developing chronic kidney disease in Black Brazilians. What this demonstrates is that genetics is not destiny, but it is relevant. The genes that people carry matter for medical outcomes. They matter for understanding disease resistance and disease susceptibility. They matter for understanding the long-term health impacts of population history. But genes don't determine identity, culture, or belonging. A person carrying majority European ancestry can be profoundly, authentically Black in every meaningful sense. A person carrying majority African ancestry can be equally Brazilian, equally American, equally part of whatever community claims them. The regional variations within Brazil itself are also telling a particular story. When researchers looked at different geographic regions of Brazil, they found that the South, which received the largest waves of European immigration in the late 1800s and early 1900s, shows the highest European ancestry percentages, sometimes reaching 74% or higher in urban populations. The North, which is closest to the Amazon and which had more indigenous populations, shows higher Native American ancestry contribution, sometimes twice as high as the African contribution. The Northeast, which was the center of the sugar slave economy and which received millions of enslaved Africans, shows the highest African ancestry percentages. But even within these regions, there is tremendous variation. A state like Bahia in the Northeast, which is often thought of as the most African region of Brazil, shows different patterns than neighboring Terra. This suggests that even within regions that received massive numbers of enslaved Africans, the patterns of mixture and migration varied considerably. The genetic data is revealing microhistories, local stories of migration and intermixture that shape the current population structure. One aspect of this research that doesn't get enough attention is what it tells us about sex and power. The asymmetric sex-biased admixture pattern that appears across the Americas is fundamentally a story about sexual violence and racial hierarchy. The pattern of European male and African female unions that dominates the genetic signature of Brazil and Latin America more broadly is not the result of consensual relationships or romantic attraction. It is the result of enslavement, conquest, and the absolute power that European men had over African women who were enslaved or colonized. In the United States, this same dynamic occurred, but it was followed by a different cultural response. Rather than the offspring of these unions being integrated into European society through intermarriage and cultural assimilation, they were pushed into a separate racial category. This is crucial to understanding why the genetic patterns are so different. Both societies experienced sexual mixing across racial lines. Both societies involved European conquest and dominance. But one society responded to that mixing by gradually blending populations and accepting racial mixture as normal, while the other responded by creating rigid racial categories designed to maintain purity and hierarchy. This does not make Brazil's approach superior or more enlightened, which is an argument that Brazilian elites have sometimes made. Instead, it created different forms of racial hierarchy. In the United States, the rigid segregation created a stronger political and cultural identity among African Americans, which fueled the civil rights movement and created a more organized collective response to racism. In Brazil, the fluid nature of race, the acceptance of mixture as normal, and the gradual blending of populations actually made it harder for people of African descent to organize around a common identity and common interests. The results have been measured in health disparities, educational disparities, and economic disparities that persist to this day. Recent studies have shown that Brazilians who self-identify as black or mixed still experience significant discrimination, still have lower average income and education than those who identify as white, and still have worse health outcomes. The fluidity of racial categories and the high rates of genetic admixture did not eliminate racial hierarchy. They simply obscured it. A society that officially celebrates racial mixture and denies that race is a meaningful category is still a society structured by race. The genes don't lie about this. The health data doesn't lie about this. The economic data doesn't lie about this. When researchers looked at the ancestry patterns of American populations, they found that approximately 50 million white Americans carry at least one black ancestor. This is a staggering number. It means that genetic ancestry and racial identity are fundamentally disconnected in the United States. Many white Americans carry African genes while maintaining white identity. Many black Americans carry European genes while maintaining black identity. The genetic data shows that racial purity is a myth. It never existed. It was an imaginary category imposed on people who were actually far more mixed than anyone wanted to admit. The implications of this research are still unfolding. Medical researchers are now looking at how genetic ancestry affects health outcomes and disease risk. They're finding that ancestry-associated differences in gene expression affect everything from immune response to vascular function to susceptibility to conditions like stroke and Parkinson's disease. Studies have shown that genetic variants associated with African ancestry can explain up to 26% of the heritability for ischemic stroke, 27% for Parkinson's disease, and 30% for Alzheimer's disease in African American populations. One specific example that researchers have identified involves the sickle cell trait. This genetic variant evolved in African populations because it confers resistance to malaria. Individuals with one copy of the sickle cell gene have malaria resistance. Individuals with two copies develop sickle cell disease, a serious condition. This variant has health consequences in the modern world, where malaria is less common but other diseases are more prevalent. Understanding that certain genetic variants are more common in people with African ancestry allows medical researchers to better predict disease risk and provide better preventive care. But here's where we need to be very careful. These findings show that genetic ancestry has some relevance for understanding population health differences. They do not show that race is a biological category. Genetic ancestry is real. Race is a social category that we've constructed. The relationship between the two is complex and indirect. Many of the health disparities that appear to be genetic are actually social. Stress from experiencing discrimination causes inflammation and affects health. Lack of access to health care affects health. Food insecurity affects health. These are not genetic causes. These are social causes, but they may show up in health statistics in ways that can be mistakenly attributed to race or ancestry. The research also raises questions about DNA testing companies and how they present results to customers. When someone takes a DNA test and receives a result saying they're 30% European, 50% African, and 20% Native American, what does that actually mean? Without historical and social context, these numbers can be meaningless or even misleading. They can reinforce racial stereotypes or create identity crises for people who've built their sense of self around particular racial identifications. The DNA testing industry has grown explosively over the past 15 years, but the companies providing these tests don't always provide adequate context for interpreting the results. Some scholars and activists in Brazil have written eloquently about this experience. One blogger, Marco Gomes, described his journey through DNA testing and what it meant to him. Others have talked about how shocking it was to discover ancestry they didn't expect. A researcher at the University of São Paulo, Tabitha Hunemeyer, emphasizes that the scars of Brazil's colonization process are too deep to be forgotten and are indeed embedded in the population's DNA. The DNA is a historical record. It tells the story of centuries of conquest, slavery, and mixture written in the genetic code. What the research ultimately shows us is that the categories of race that we use to organize society are human inventions, not biological facts. They are social categories layered on top of a much more complex genetic reality. The difference between Black Brazilians and Black Americans, then, is not simply genetic. It's historical, social, political, and cultural. The genes tell part of the story. The history tells another part. The way communities have organized themselves around race and identity tells yet another part. And the way that governments have made policy choices about immigration, mixture, and belonging tells yet another part. Looking forward, this research will continue to generate important insights. The DNA do Brazil project will ultimately sequence 100,000 Brazilian genomes, creating an unprecedented resource for understanding human genetic diversity and health in an admixed population. Similar projects are being planned in other countries. The 1,000 Genomes Project and other massive sequencing efforts are creating databases that will allow researchers to understand human genetic variation in far greater detail than ever before. But as this research continues, it's important to remember what it can and cannot tell us. It can tell us about ancestry and admixture. It can tell us about disease risk and health outcomes. It can tell us about population history and human migration. It can tell us about the legacy of colonialism, slavery, and immigration written into our genetic code. What it cannot tell us is who we are, where we belong, or what our identity should be. Those are questions that each person in each community must answer for themselves. The genes may determine our susceptibility to certain diseases, but they don't determine our character, our culture, or our humanity. A person with 70% African ancestry and 30% European ancestry is not confused about their identity. They are a complete person, a full human being whose ancestry is simply part of their history. Someone with minority African ancestry can be deeply, authentically connected to African diaspora cultures, African American communities, or African heritage. Someone with minority European ancestry can be equally connected to European culture or identity. Genes are not destiny. They are information, data points, in a much larger story about who we are and where we belong. The real revolution that genetic science has created is the ability to see history written in DNA. Every person who has ever lived is the product of millions of years of human migration, mixture, and survival. Most modern humans carry the genetic legacy of multiple continents in their bodies. The genetic diversity within Africa is greater than the genetic diversity between Africa and Europe. No single genetic marker defines an entire continent or an entire people. What the research on Black Brazilians and Black Americans ultimately shows us is that the story of race in the Americas is not a story written in our genes. It's a story written in our history, our laws, our policies, and our choices about how to respond to human difference. Two men, one from Salvador, Brazil, and one from Atlanta, Georgia, standing side by side, might have very different genetic ancestries. One might be predominantly African, another might carry equal parts African and European and Indigenous American ancestry. But what unites them is something far more powerful than genes. It's the shared experience of navigating a world that has been shaped by racial hierarchy. It's the shared connection to African diaspora culture, to music and food and movement that carries the echoes of ancestors. It's the shared understanding that their humanity has been questioned. Their worth has been weighed on scales designed to find them insufficient. As we move forward into the future, genetic science will continue to advance. The DNA do Brazil project will be completed. The databases of human genetic variation will grow larger and more detailed. We will understand more about how genes relate to disease, to function, to human variation. But understanding these things will not require us to accept that race is biological. It will not require us to sort ourselves into hierarchies based on ancestry. Instead, it offers us the opportunity to finally see ourselves clearly, to understand our true genetic diversity, to recognize that every human carries within them the legacy of ancient migrations and ancient mixtures, and to build a future where that knowledge creates not division but deeper understanding of our common humanity. Two groups, same continent of origin, 100 years of separation, but not so different after all when you understand what shaped them. The answer was not in the genes alone. The answer was in history. The answer was in policy. The answer was in the choices that governments made, and that communities made, and that individuals made about how to respond to difference. And that understanding, more than anything else, is what the DNA is really telling us. The DNA reveals history, but we create our own futures.